Hello, everyone. Can I start?
Ну, следующий пошел.
Yes, okay. Sorry. One moment, please. Okay. Good afternoon. My name is Daria Gordieva. Today I would like to present a report on the topic relation between software defects and factors influencing the software development process. This slide presents a brief structure of our report. First of all, I would like to talk a little about current state of the cost of post-software quality. Global information technology industry is approaching the achievement of spending on information technology to about $5 trillion in 2023. The US market share is 36%, and the consequences of poor software quality are estimated about $2 trillion per year, and this amount tends to increase. Among the identified costs, the cost of unsuccessful IT projects is estimated at $260 billion, and the total cost of software failures caused by poor quality software is estimated about $2 trillion. The main cost categories associated with poor quality software always include expenses for finding and fixing software defects, which amount to $608 billion per year. Today's software is remarkably complex, comprises thousands of lines of code and a huge amount of defects. 111 billion lines of new software code are created annually, serving as a source for potential vulnerabilities as a result of developer mistakes. In typical software code, there are on average 25 mistakes per every 1,000 lines. Reducing the number of defects in software entails a substantial increase in expenses related to assessment and ensuring its quality. The company CAST in its Crash 2020 report analyzed about 2,500 applications to describe the effects of different industrial factors on structural quality of IT applications developed across the globe. They found that while structural quality differed slightly across industry segments, the factors that most significantly influence quality are barely affected by source and shore factors and depend on the applications, technologies, the development team, and the specific conditions in the development environment. The software testing company Recentys carried out an automatic analysis of news from authoritative internet news resources and published the 5th edition of the Software Fail Watch, in which identified 606 recorded software failures in 2017 year, impacting half of the world's population and cost about 2 trillion in lost revenue. On the figure 1, unique software defects news is grouped into the following categories: entertainment, finance, government, public services and healthcare, retail and transportation. We can see that retail and government industries experience the most software failures of any industry analyzed in 2017 year. The first and common cause of software failure is software code defects. A second type is security vulnerability, and third type usability defects. The cost of finding and fixing defects is the largest single expense element in the software development lifecycle. The complexity, accordingly, the cost of finding and fixing software defects depends on the stage of the software development. The later a defect is discovered, the more difficult and expensive it is to fix. Considering the increase in the cost of a defect during the software testing stage, the standish group has developed what is called the rule of 10, which states that after each level of quality assurance, it will cost 10 times more time and money to correct and eliminate a defect than at the previous stage. The main objective of our paper is to identify the relation between different domains of defect and factors that affect the software development process and lead to software project success or failure. The reason for success or failure of a project are different and depend on the size of the project management methodology used, the team staff, the industry in which the project is being implemented, etc. In current literature, the most popular source for providing data on the number of successful and failed software development projects is the Standish Group House report, which provides statistics from the software development industry. According to the Standish Group House report, recently only 35 of projects were completely successful. 19% of projects were cancelled before completion, and about 47% of projects encountered issues like exceeding budget, falling behind schedule, and achieving low quality results. On average, starting from the 2000s year, despite the development of new technologies and the implementation of new project management methodologies, the frequency of unsuccessful projects has remained around 20% for many years. One reason for this trend may be that the complexity of projects has increased and the time to complete them has decreased. To figure out the relationship between the domain of defects that occurs at different stages of software development and the factors that affect the software process, and accordingly the success of the project completion, we took as a basis the most popular study of the Standish Group, based on 8,000 projects and involving about 400 information technology executive managers of large, medium, and small companies across major industry segments. According to the result of the study, the project success, project challenged, and project failed factors and percentage of their impact were determined. We correlated similar factors among successful, challenged, and failed software developments group and established possible connection between them. We analyzed 3 top factors with the highest percentage of influence on software development. Factors related to form and software requirements and specification were mentioned 4 times in all of these groups. Of factors with average impact percentage of 12.6%. Factors associated with the user involvement for forming focus group for evaluating the usability of software interfaces were mentioned 3 times in 3 groups with the average impact percentage of 13.7%. Other factors that enter in the triples ones include management support and lack of resource. To figure out the relationship between the factors that affect the software process and the domain of defects that occurs during software development, we correlated these factors and groups of software defects. To do this, we defined the following logical domains of the type of the software defects, like defects in software requirements, in design of software interfaces, coding defects, testing and verification defects, defects in software development planning, design defects, and defects in software development management. Therefore, the leading domains of defects affecting the software development through influencing listed factors of success or failure are the domain of defects in software requirements and the domain of defects in design of software interfaces, with a total percentage of influence of 36.3%. The number of defects increases with the size of the application. However, defects in requirements and design of interfaces increase at a faster rate than coding defects. Testing primarily focusing on code defects that are usually easiest to fix. For large systems and large applications, coding defects are not the main source of problem, while finding and fixing requirements defects and design defects is very expensive and labor-intensive. Defects introduced at the stage of software requirements formation constitute 50% of the total number of detected software defects. Fixing a defect at the stage of requirements formation is always cheaper than at any other stages. Changing requirements have a higher potential for defects than original requirements due to rushing and lower defect removal efficiency rate due to skimming on quality control. So requirements changes make the most significant contribution to overall software application defects. Involving users and requirements development stage throughout the entire software development lifecycle helps to avoid the occurrences of defects in the software interfaces. Projects that lack of user involvement often fail, and about 67% of projects where user involvement is rated as highly skilled are successful. The study, The True Cost of a Project, found that user involvement was the second largest driver of hidden cost that directly led to budget overruns, eclipsed only by software development. To sum up, we can say that a relationship between different domains of defects and factors affecting the software development process were established. Leaders among defects affecting software development due to the factors of success or failure software project considered and defects considered are defects in software requirements and defects in the design of software interfaces. It's the biggest part of defect with a total percentage of influence 33.3%. Our future research will be aimed at the more detailed study of defects and methods for their findings. Thank you for your attention. If you have any question, please ask me.
Thank you very much, Daria, for your very interesting reports. Have you questions, dear colleagues, for Daria? Okay, I have small okay. Sergey, please, your question.
Hi, Daria. Thank you for your presentation. About the combination of the factors which influence the success of software projects you mentioned. This is an interesting discussion, but I wonder, have you considered the possibility of examining, of getting and like a data set of projects, as opposed to review, like the study of a kind of an opinion review? Because one of the concerns here I have is that after the fact, people may, so it's the objectivity basically of the information. Because people can form their opinions based on the outcome of a project. So it's not necessarily the factor which actually influenced the success or failure of a project, but people's opinion after the fact, what could have gone wrong in the project. So this kind of direction, I'm just wondering if have you considered it. Thank you.
Okay, as I understand your question, no, maybe I understand incorrectly, but we study some.
How objective is input information for the analysis? Is it people's opinion, or is it like something which measured objectively?
Yes, it was our research were based on the survey about. It was empirical research. It was opinion survey, because we couldn't find data set with, no, for example, data set with all mentioned defects which people find in their unsuccessful or successful projects. Majority of existing research it's or empirical research based on opinion survey, or systematic review about success or failed factors. So yes, it is very difficult to find real factor. Usually it's on they determined on the people opinion, and sometimes it depends on how researcher ask this question. So if we analyze different research, we understand that result of this research are very difficult and depends on who ask about this factor. It's stakeholders, or it's developers, or this is users. So it's very difficult. Different factors depends on the people who ask this question.
Yeah, that's what I thought. Thank you.
Thank you. I have small questions. Please, Daria, do you think the type of software development life cycle affects the number of defects, program defects during development process, and the detected program defects during verification, validation, testing process?
So maybe I don't understand the question. So how many defects on the different
life cycle?
Yes.
Affected number defects.
Yes.
Introduced and detected.
No.
During life cycle phase, stage life cycle, development and testing.
No, but we understand that we can't detect all defects. Some part of defects always inside our software, and we can detect them after production. Usually it's maybe it's like I read in many research that on average it's 10% of defects we cannot detect on each life cycle. So on the if we test our defects like on the unit tested, we cannot find about 10% of defects. So these defects put on the next stage of testing. So in statistics, usually the main problem with requirements, with defects in requirements. So coding defects, usually it's easy to find and fix. So I don't know. I ask.
Thank you very much.
I answer to your question or not. Maybe I don't understand clearly.
Okay, thank you. Thank you very much, Daria. The next report